All right, we're going to finish up that example that we did. We didn't quite get to it. This is example 4. And let's try to write it down again. Let's see if I can get this to work. So it's the cube root of 8x to the 4th plus the cube root of negative x plus 4 times the cube root of 27x. All right, here we go. Now we're ready. So what we're going to do, you got these things that are being multiplied inside of here, inside of the roots. So what we're going to do is we're going to separate them. All right, this is a cube root, so we're going to separate these two things. So we're going to take the cube root of 8, and then we're going to take the cube root of x to the 4th. Everybody see that? That's where we start, all right, because they're not like terms, right? Like this and this and this, they don't look all the same inside there. This is x to the 4th. This is an x. Well, that's got an x too, but this has got a negative. All right, so we got to simplify each of these 3 before we do anything else with it, before we try to add them together or anything. So let's do this. Let's do the cube root of 8, and then we multiply it by the cube root of x to the 4th. And we'll work on this in the next step, okay? All I'm doing right now is just splitting them up. Now you say there's nothing to split up here. Well, there kind of is. What's being multiplied by the x? A negative 1, okay? Very good. So what I'm going to do is this. I'm going to take the cube root of negative 1 and then multiply that by the cube root of what? Just x. See what I did? So I split that one up as well, because this is negative 1 times x, so I split them under their own cube roots. Because it's negative 1 times x is negative x. All right, you don't see the 1 there, but you know it's always there. All right, plus 4, and then this is going to be the cube root of what? Let's split this up. What's that going to be? 27. Now, you don't have to put the 4 again, because the 4 is only being multiplied 1 time by this stuff, so I'm just going to split this up. Oops, not square root, it's cube root of 27, and then this is the cube root of what? X, okay? So that's the first thing we do. That's not really that difficult, is it? All right, no, we just split up the things that are being multiplied in here, just put them all under a cube root, and now we can actually do some simplifying. We haven't really simplified too much just yet, but now we're going to simplify. So the cube root of 8, you should be able to do that in your head. We've done that at least 3 or 4 times already. It's just a 2. What number times itself 3 times is 8. 2 times 2 times 2 is 8. So the cube root of 8, that's one of those things you just be able to look at, and you should be able to just say the cube root of 8 is 2. All right? So that's a 2. What about this one, though? I'll tell you what. Let's do this. Let's do this off to the side a little bit. All right? This is off to the side. All right? And x to the 4th. We've done something like this before. Well, it will, but we got to write it something so something cancels out. So how are we going to rewrite x to the 4th? Now remember, you got a cube root, so I want to write it x to the what? To the 3rd, or x cubed, times x. All right? So I'm just not showing all the steps right here. I'm doing a little bit of the steps off to the side. Then I'm just going to write it down. It just makes it a little bit more, just prettier to look at, okay? So what is the cube root of x cubed? Because I could split it up, right? Like this. The cube root of x cubed times the cube root of x. Yeah? What's the cube root of x cubed? We talked about this. It's real simple. It's just x. Why is it x? How do I know? That's right. The cube root and the cubed, they cancel each other out. That's why I took x to the 4th and I wrote it as x cubed and then an x, because I wanted it to cancel out with that cube root. Make sense? Yeah. Okay, so I'm going to come over here. What do I have? I got an x, and then what else do I have? I got a cube root of x. You see that? So this is just like 2x. Let's just write it and not put that little dot in there. This is just like a 2x. So it's 2x times the cube root of x. That's simplified. That's this thing right here. That's completely simplified to be that. All right, let's keep going. Plus. What do we have here? What's the cube root of negative 1? What times itself 3 times is negative 1? Negative 1. Negative 1 times negative 1 is positive 1 times another negative 1 is negative 1. So the cube root of negative 1 is negative 1. Can you simplify the cube root of x? No, I can't do anything with that. It's already broken down as far as it can be. Now, if you look at this, look at your like terms. Remember, if I add 3a plus 2a, what's 3a plus 2a? It's 5a, right? So you just keep the a the same. Same thing here. I got 2x and then times this, cube root of x. So you have a cube root of x here, and I got a cube root of x here. So I got like terms, don't I? Let's see if I have like terms over here. I probably will. Let's do this part over off to the side here. Is that all right? So it's 4 times the cube root of 27. Here's another one. I said you should have cube root of 8 memorized. You should have the cube root of 27. We've done that a bunch of times. It's 3. So what is this? This is 4 times what? 3, which is 12. So what's this whole thing right there? That's just 12. See that? I could have done the step down in here, but I just did it off to the side. So 4 times the cube root of 27, it looks real crazy, it looks real funky, but it's not that hard. Because the cube root of 27 is 3. 3 times 4 is 12. We good? Yeah. All right, and then what do you write down now? The cube root of x. We haven't added anything just yet. The only thing that we've done was we've taken this and we simplified it. We've taken this and we've simplified it, and we've taken this and we've simplified it. Now you're actually ready to add like terms. It's all right. So watch what we have now. Let's add some like terms. What if I did this? What if I had 2x? Now, that's going to confuse you more than that. Oops, what did I just do? V, that's what I wanted. Forget that. Let's just do this. Do I have any like terms? Sure, all 3 of them are. All 3 of them have a what in common? Not just an x, a cube root of x. This has cube root of x, this has cube root of x, and this has cube root of x. Do you agree? Which do all 3 of them, are they exact? Can you add all 3 of them up? Not really, because this is a 2x and this is a minus 1. Can I go 2x and minus 1 and combine them? No. All right, but I can combine what? This is a negative 1 and a positive 12, right? You with me on that? So what's negative 1 plus 12? It's 11, and what's my term that's associated with it? It's so it'd be like this. It'd be negative a plus 12a. What's negative a plus 12a? 11a. But this is not an a. What is it? It's the cube root of x. Okay, so I got negative 1 cube root of x plus 12 cube root of x. So how many do I have altogether? I have plus 11 cube root of x. Do you see how we're adding like terms? It's just like adding super simple stuff like this that you learn when you're in middle school. You didn't do this in middle school, okay? But it's the same idea. They're like terms. What can I do with this 2x? Can I combine 2x and 11 and get like 13x? No, because this has got 2x. This is just an 11. So really, what's the only thing I can do with this? Just bring it down. That's it. I can just write 2x times the cube root of x. If you wrote your answer like this, I'd probably give it to you because it's simplified right now. Okay? But I'm going to show you what the book does. These two things have the cube root of x in common, don't they? So what did we just finish doing a whole section on? Factoring, right? And we always look for greatest common factor, right? Do they have something in common? Yeah, they got the cube root of x in common. Agreed? So I'm just showing you how the book. If you wrote it like this, I would give that to you. It's simplified. Aspen, you watching? Yeah. I don't think so. So watch. So a cube root of x is in common. So I could factor it out, couldn't I? If I factor out a cube root of x from this, what am I left with? A 2x. What if I factor out a cube root of x from this? What am I left with? 11. This is how the book writes it. It's not that bad, okay? Either way, I'll accept either way, all right? But this is, if you look in the back of the book, I always give you the odds, don't I? So what should you, I don't know if you're doing it or not, but what should you be doing after you do a problem? You should be going to the back of the book to see if you got it right. You should not write down number 1, look in the back of the book, see the answer, and write the answer down. I know some of you guys are doing that, all right? There's nothing I can do about that. You're just hurting yourself. But you do the problem, okay? You do the work, you look at your answer, you look in the back. If it's right, keep going. If it's not, what should you do? Should you keep going? You should try to figure out what you did wrong. If you can't figure out what you did wrong after just a few minutes, go on to the next problem, okay? But I would sit there for several minutes, try to figure out what I did wrong so I can get the answer that they have in the back of the book. That's why they put the answers in the back, okay? They don't do it so that you could cheat, all right? They do it so that you know if you're getting the answers right or not. Because that would be terrible to have all these problems to do and not knowing if you're doing them right. And then you're doing 50 problems, right? Not literally doing 50, but you're doing a whole bunch of problems and you don't know if you're doing them right or not. Okay, that would be tough. That's why they put it in the back. All right, enough of that. Let's move on. That was basically from Friday's lesson right there. All right, so let's go to today's lesson. And what do we call it? Rationalize the denominator. We're still on R.8, okay? We're going to be on R.8 for probably the rest of this week until we take the quiz on Friday, okay? Yes, quiz on Friday. So we're going to rationalize the denominator. What in the world does that mean? Well, it says denominator, so we must have a what then? Yeah, yeah, but we must have a fraction, right, in order to have a denominator. Yeah, I thought denominator was pretty self-explanatory, but yeah, we got to have a fraction, right, in order to have a denominator. So let me just show you something real quick. I'm not really sure why. Everybody's listening, right? I'm not exactly sure why, but mathematicians long time ago, they probably had a reason for this. They decided they did not want square roots or any roots in the denominator. They're like, okay, you wrote your answer like this. I don't want you to write your answer like this. I don't want any square roots in the denominator. All right? I'm not sure. Mr. Rao, do you have any idea why they don't like square roots in the denominator? Listen, hey, stop.
If we have 1/2, 1/7, then it's easy to see, oh, it's 1 out of 7. If it's 1 out of square root of 3, you don't have that same connection. So you
Okay.
rationalize the denominator to get a whole number down there.
Okay.
Is it 2 out of 7?
Right, just divide it by a whole number. Right. Okay, sounds good to me. All right. See, isn't it awesome to have Mr. Rao in the room when I'm teaching? It's great. So here's what you can do. Everybody listen. So here's how you rationalize. And when we say rationalize the denominator, we're going to turn this fraction into something else that's still equal to this, but it doesn't have a square root in the bottom. You hear what I just said? We're going to change this fraction so it's still equal to this. Okay, it's not going to be anything different. If you stuck it in your calculator, you'd still get the same exact thing. But it's not going to look like this because it's not going to have a square root in the denominator. We good? So how do we do that? Well, what we're going to do is we're going to multiply it by 1. I'm not just going to go times 1. Why is that not in red? Oh, it's because I changed the wrong thing. I got to change that to red. But what we're going to do is we're going to multiply it by something that's going to get rid of the square root in the denominator. Okay, very good. So watch. If I had the square root of 3 and I multiplied it by itself, what's going to happen here? It's not going to equal 1. But what am I going to be left with? What's my answer to this? It's just a 3. It's not a 9. It's the square root of 9, right? But what's the square root of 9? It's a 3. Anytime. We talked about this the other day. Even if I had some weird number like the square root of 17 times the square root of 17, I have no idea. Well, I think I do. This thing is 289. But normally, I wouldn't have any idea of what 17 times 17 was. I'd have to put it in my calculator and then put it into the square root. But I don't have to do that, because when I'm squaring something, or when I'm multiplying something by itself, basically, I'm just squaring it, aren't I? Yeah? So what happens to the square and the square root? They cancel each other out. I'm just left with that number underneath of there, that whole number. You with me on that? Okay. So what we're doing is we're using that information right there to get rid of the square root. How can I take a number that's in a square root, and how do I get rid of the square root? I multiply it by itself, and that'll get rid of the square root. Would you agree? So right here, how do I get rid of this square root and leave it just a 3? I multiply it by itself, the square root of 3. Now, can I just haphazardly multiply anything I want by a square root of 3? No. If I multiply the bottom by a square root of 3, I have to do what? Multiply the top by a square root of 3. Remember what I said earlier? How are we going to get rid of this? I'm just going to multiply by a what? What am I going to multiply by? A 1. What's the square root of 3 over the square root of 3? It's a 1, isn't it? So would you agree? Now, what happens when I multiply stuff by 1? Nothing. Nothing changes, right? I don't change anything, right? So did I change the value of this original fraction? No, I did not. Okay, but I did make it so that I get rid of the square root in the denominator. Are we allowed to have square roots in the numerator? Yeah, that's fine. They just don't want you having square roots in the denominator. I shouldn't even say square roots. I should say any roots, okay? So no radicals in the denominator. We got it? Okay, that's what they mean by rationalizing the denominator, all right, is to get rid of the square roots or any root in the denominator. So what do we get? What's the square root of 3 times square root of 3? No, it's 3. It's right here. We just did it. What's 1 times the square root of 3? Okay, so 1 over the square root of 3 is the exact same thing as the square root of 3 over 3. I'm not going to do this, but anybody got a calculator out? Carter, you got a calculator out. Punch in 1 divided by square root of 3. What do you get for a decimal? 1 divided by the square root of 3. Give me a, no. Give me a decimal. I said, give me a decimal. 0.57, blah, 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 right? Okay, and then what's the square root of 3 divided by 3? No, it's not. The square root of 3 divided by 3 is not 1. It's 0.57. I'll tell you right now. If 1 divided by the square root of 3 is 0.57, then the square root of 3 divided by 3 is not 1. It's not. You're not doing it correctly.
Put it in your calculator, Mr.
I will. My goodness.
What's the square root of 3 divided by 3?
It's not 1. And he'll right. What? So now you're not believing me? You got to go to Mr. Rao because you don't believe me?
Yeah, you go to Mr. When you don't believe in yourself, you go to Mr. Rao.
That's true.
I go to Mr. Rao.
But I believe myself on this one. All right, look. Let's see. I don't think on YouTube they can see this. Oh, yeah, they can. Okay. Let's try this again. All right, let's try it. Everybody look. Everybody look. 1 divided by the square root of 3. Square root of 3. So everybody look. Guys, you're not looking. I said 3 times. Look at the screen. Look at the screen. How hard is it? All right, there it is. 0.577, blah, blah, blah. Okay. But now, let's put in... Shh. Settle down, guys. It's only Monday. Let's put in now the square root of 3 over 3. So let's put in the square root of 3, square root of 3. I'll close the parentheses. And we'll divide that by 3. Just because I want to. And look at that. It's the exact same number. Okay? So my whole point is that 1 divided by the square root of 3 over... Or 1 divided by the square root of 3 is the same thing as the square root of 3 over 3. And I just showed you on the calculator that they're the same thing. All right. And it does not equal 1. The square root of 3 over 3 does not equal 1. Now, the square root of 3 over the square root of 3, that does equal 1. But not this one right here. All right, let's move on. We have bigger fish to fry here. All right. You never heard that? By the way, this is example 5. That was example 5A. This is example 5B. My word. Is it a full moon today or something? My other class was crazy, and this class is crazy. Okay, here we go. Actually, I'm not going to put equals yet. We need to simplify this. Yeah, you're the only one. Here we go. Why is this not simplified right now? I mean, nothing will cancel. Like 4 won't go into anything here. Why? Because the square root cannot be in the denominator, okay? So it's not simplified. So if they ask you to simplify this, you have to get rid of that square root. So how do you get rid of the square root of 2? Multiply it by itself, right? That gets rid of the square root. So if I multiply the bottom by the square root of 2, I also have to multiply the top by the square root of 2, because in red, what are we doing here? We are multiplying by a 1, all right? Because square root of 2 over square root of 2 is 1. And I'm allowed to do that, right? I'm allowed to multiply anything by 1 because it doesn't change it. It doesn't change the value of it. But it does change the look of it, though. So let's do the top right now. How do I multiply 5 times the square root of 2? Is that the square root of 10? No. It's just 5 square root of 2. Because this is a whole number. This is a square root. We cannot multiply a whole number and the thing that's inside the square root. If this was a square root of 5, it's not. But if it was, then it would be square root of 10. Okay, it's a common mistake students make. They'll see 5 and then the square root of 2, they'll make the square root of 10. It's not the square root of 10. It's 5 square root of 2. It's the only way you can write it. Okay? No, not done. So look, now we got a 4 here, right? Let's multiply square root of 2 times square root of 2. Easy. Which is? Oh, goodness gracious. So now we write it like this. It's 4 times 2. This is a whole number 2 now. It's not a square root. It's just a whole number 2. And this is a whole number 4. We multiply it together. We get an 8. And now that's simplified. Does 2 cancel out with this 2 and this 8? No, because this is under a square root. It's not just a 2. It's the square root of 2, which means what number times itself is equal to 2. All right? It's like 1.14 or something like that, I think. All right? But nothing cancels out. Now it's simplified, and that's it. Let's do another one. Let's do C, and then we will be finished. And then you should be able to do all the problems from 7 to 53, the ones I originally assigned you. So this is the last part of this homework section. We got more to do on R.8, but here we go. It is kind of easy. It's not bad at all. I'm going to show you one other thing. Now this, it's a little different. It's a little different. So for all the ones that are having their little conversations going on, I would recommend that you stop, because you will be completely lost if you're not watching this. Let me do this. No, I'm not gonna try to give you an explanation. I'm just gonna show you. Okay? Let's do this in red. Now this is a little different. What's different about this compared to up here? We still got square roots in the bottom. But what's the big difference? Nope, you can't. Because you got a what? Yeah, you got 2 square roots, but more importantly, you have what in between? You have a subtraction. That thing right there. Okay? That's different. That's a lot different. So shh. Don't say anything. Just listen. Here we go. In order to rationalize the denominator, when you have 2 things that are being added or subtracted, okay, we multiply. Here's a new word for you. We multiply something called the conjugate. Conjugate. Very good. All right. It's an English word, right? Like in English class, right? You conjugate verbs in Spanish, you conjugate verbs, right? This is a different conjugate, okay? We call it the conjugate, okay, instead of conjugate. It's a noun instead of a verb. So we're going to multiply by something called the conjugate. The conjugate is very, very easy. The conjugate, it's the same thing as this, except we just change the sign that's in the middle. You hear what I just said? So the conjugate is the same thing as this, except with the different sign in the middle. Okay, it would be plus, exactly. So what we're going to do, and I'll show you, it works every time. We're going to take this, and we're going to multiply it by its conjugate. The conjugate of this. What's the conjugate of this? Square root of 3, what? Plus 3 square root of 2. And you say, why do we do that? Well, we do it because it works. And I'm just going to show you why it works. I'm not going to go through an explanation on why it works. Let's just show that it works. Okay, so now watch. Just like we did over here, we can't just multiply the bottom by some random thing. We're going to have to multiply the top by the same thing. And why do we do that? Because we're making it a what? A 1, right? So what do you think I'm going to do on the top here? Multiply it by the same exact thing that's on the bottom. Okay? So that's the key. Multiplying by the conjugate. And the conjugate's easy as far as figuring out what the conjugate is. It's just the same thing, except you just change the sign that's in the middle. You with me? Okay. Now, hopefully, you remember how to do distributive property and FOIL method. The reason we learned that earlier is now we can actually apply it again. So don't forget the stuff that we learned earlier, because it always comes back. All right? I almost said to haunt you, but hopefully it's not going to haunt you. It's going to help you. So I only have 3 minutes left. I got to do this quick. Let me show you why we multiplied by the conjugate. So we're going to do FOIL method. If you look at this, this is kind of like if you had a difference of 2 squares, right? It looks like the answer to a difference of 2 squares. So let's just do the FOIL method. Okay, square root of 3 times square root of 3. What's that? It's 3. Okay, that's the first. Now watch. The outside, I don't even have to do the math because I want to show you this. The outside is 3, or square root of 3 times 3 square root of 2. The inside is minus square root of 3 times 3 square root of 2. That's right. The outside and the inside, they just add up to 0. I don't even have to do the math with that at all. I just look that they're the exact same thing, except one's plus, one's minus. That means they're going to add up to 0. So the outside and inside, I'm not even going to worry about. I just know they go to 0. Now let's do the last. Negative times positive is negative. Now let's do a little bit in our head here. 3 times 3 is 9. And then the square root of 2 times the square root of 2 is 2. And so what's that going to be? This is going to be 18, isn't it? And what's 3 minus 18? Negative 15. All right? Are you with me so far? Yeah. Let me find out where my problem is here. There it is. Okay. So now I got my denominator. Now let's do the top. What am I going to have to do with that square root of 2? I'm going to have to distribute it through here. So let's do this up here. What's the square root of 2 times the square root of 3? It's the square root of 6. It's not just a 6. It's the square root of 6. Plus 3 times, what's the square root of 2 times the square root of 2? Square root of 4, which is 2. 3 times 2 is 6. So what's the top? The top is just the square root of 6 plus 6. I can't add those together. It's not 12. It's not square root of 12. They're completely different numbers, okay? So I can't add them together. They're different styles, okay? That's the square root of 6. That's the 6. And that's it. That's your answer. You could write your answer like this, though. Do you remember? Bell's about to ring, so just hang on. Negative 2 over 3. Isn't that the same as 2 over negative 3? Or I could write it what? The negative right in the middle. Agree? Yeah. So you could, I'll put an or, you could write it like this, because you might see it like this in the book, right? You might see the negative right in the middle, and then you'll see the square root of 6 plus 6, and then the 15 on the bottom. Either one of these is perfectly fine. now you're ready to finish 7 to 53 odds. Okay? So this will be due tomorrow. And tomorrow's a question and answer day. All right? So that's all we're doing is answering questions on 7 to 53. We're not doing anything new tomorrow.